This is MAP4C, day 5. The lesson is 1.4, the sine law. We see yesterday's goal, and we've got a few things to do in the 3-minute review. What do we say, day 5? But we wanted to determine trig ratios of obtuse angles. That's what we were doing yesterday. We were talking about all these strange business about taking sine and cos of obtuse angles. And we're also reviewing some stuff from earlier using SOHCAHTOA to solve real-life problems. So what have we got here? Number 1, circle the equations where angle A is obtuse and put a box around equations that have 2 solutions. So remember, an angle A is obtuse when the sine, not the sine, the cos, and the tan are negative, right? Are negative. And equations that have 2 solutions is anything sine A is equal to some positive number here. Okay, that's the ones that had 2 solutions. So if we just go through and pick them out, put a box around the sines, one acute solution and one obtuse solution. I don't know how that B got in there, eh? It should be an A, I guess. And then any ones that had a negative cos or negative tan would be an obtuse angle. So we'd circle those ones. So I'm going to circle that one. I'm going to circle that one. And what's left over are tans and coses, where A would be an acute angle, just like when we're solving triangles using SOHCAHTOA from grade 10 and 11. And again this year, but not an obtuse angle. All right, let's keep going here. What do we got? Find x in each diagram. So in this case, notice that we've got 2 right angle triangles, 2 SOHCAHTOAs. I'm going to write SOHCAHTOA here just so I can see it. It's a bit of a mess. SOHCAHTOA. Here, SOHCAHTOA. We got 2 triangles, one here and one here. Notice that if we consider this one, the one that the x is the hypotenuse in, we don't have a side given. We don't have that side, we don't have this side, and we don't have the side that we need. And so in this case, we're kind of stuck. Well, what we can do is we can treat this as a 2-step problem. We can find the height of the triangle from this side, from this little triangle at the side. We'll call that the height. And then in the second step, we'll find x. Well, we've got some imperial units we've got to take care of. 2 feet is 24 inches. So altogether, 24 and 8, that's 32 inches. Hopefully that never threw anybody for too much of a loop. And then here to get h, that's the opposite and the hypotenuse. Opposite side hypotenuse. Opposite and hypotenuse, this is the sine. So we have the sine of 63 degrees is h over 32. Going to find h here, 32 times that. H is about 28.5. What's that? Inches. And then I can do a second step to find x. So if this is 28.5, write that in there. Then I have the opposite side, and I need to find the hypotenuse. Again, opposite and hypotenuse, that's the sine of 28 is opposite over hypotenuse. We don't see the hypotenuse as an unknown very often unless it's Pythagorean theorem, but that's okay. It's not going to throw us for too much of a loop. Multiply through by x, so we get everything on the same plane here. And this was, maybe we think of this as an extra step, I don't know. Divide by sine 28 on both sides. You put that, jam that into a calculator, and you get about 60.73 0.3 inches, which again, this is weird having decimals of inches. There's a couple things wrong with this number actually. Too many inches for one thing. Usually we'd write it as feet and inches. So 60 inches divided by 12, that's 5 feet even, right? So that's 5 feet. And then 0.75 or 0.73 is about 3/4. It's about 3/4 of an inch. So it's 5 feet, and 3/4 of an inch would be sort of the most accurate, sort of Mr. Faber way of writing that. Of course, our textbook would be okay with the decimals, and I'd accept that on a test. B here is actually the 3-minute review from yesterday, without the situation attached to it. So if you want to see that one explained, you can look back to yesterday's video. Hopefully you tried it and you got a value that x was 178 meters about. And number 3, this is questions like number 3 are one of my favorite types of thinking questions, where here's the situation and you have to come up with the context. You have to come up with the application for where that it might fit. So obviously in part B, that was the one of the person looking out at another building. The angle of elevation was something, the angle of depression was something else, and you had to find the height of the other building, right? This was the 3-minute review from yesterday, so that would be that context. For this one, well, you just make something up, really. It would be something that would have to fit these dimensions. Like this wouldn't be the roof of a house. These are too small, but maybe it's the roof of a doghouse or something like that, where, you know, one side of the doghouse is 32 inches and the dimensions, so you get the right slant on the roof that you want. You want to find out what the other side of the doghouse would be, something like that. And so you can make that up. All right. So that's the 3-minute review. Let's get into the lesson today. The lesson today is on the sine law, and I think some of you have been itching to use the sine law, especially in cases like the 3-minute review, where if we use the sine law, we wouldn't have to have 2 steps. It would be a 1-step thing. And if you remember the sine law, there's actually 2 versions of it, but they're really the same thing, right? This one has the angles on the top, sine of angle A over A, sine of angle B over B, and so on. And this one has the sides on the top, right? Sides are with the little letter A's, and angles with the big letter A. Now, it's kind of a funny story here about this. I was in England and ran into Paul McCartney. He's unbelievable, and he was having problems with the sine law, remembering the formula. And so I wrote a little song for him, and if you ask real nice, we'll play that in class for you. I couldn't figure out how to get it into this video, but remember to ask about a Paul McCartney story or a Paul McCartney song. McCartney, how do you spell McCartney? Like that. That I wrote for him to help him remember the sine law. But we just have to remember. We just need to remember it ourselves for the test, and we need to be able to use it. So let's see some examples. The big thing for the sine law, to use the sine law, we need an angle side pair. And I'll tell you what I mean. So in the sine law, one of these things has to be known. We have to have both angle A and side A, or angle B and side B, and angle C or side C. One of these things need to be known. So the way I see it is an angle side pair known, and I do a loop like that to show what angle side pair we have. So in this one, we want to find side A, right here, right across from angle A. But where's our angle side pair that's known? Well, we've got angle B and we've got side B. So there's the loop. There's the known angle side pair. And so now I can write it down. I'm going to have side A as my unknown, so I'm going to write the version of the sine law with the sides on the top. And in fact, I like having my unknown front row center here, right at the top on the left, although other versions would also work. And some of you, I know, want to substitute in straight off and get right to this line. And I suppose after you practice a bit, that would be okay to skip to this line right here. And then this is my angle side pair that I know, side 24, sine of 15 degrees. And now I want to solve for A. Well, how do I solve for A? I've got to get rid of dividing by sine of 140, right? So I multiply by that. And I can put that in my calculator. 24 times sine 140 divided by sine 15, just exactly how it appears, is about 59.6, and no units here, so we'll just call that units. And notice, does that make sense? Well, that's 26 and that's 24 and that's 59. Yeah, that seems, it's a lot longer than the other two sides, although these diagrams are never drawn to scale, but that looks okay. In the second one, we want to find angle B. We want to find this angle. We've given the opposite side. Where's our angle side pair? Well, we know A. Right, so I'm going to write down, we need an angle, so I'm going to use the version of the sine law that has the angle on top. And again, some people aren't writing down this step. You can skip to the substituted step if you're not making any mistakes. Over 5 equals sine A, which is 50, over side A, which is 4. And now I cross multiply. And sine B is equal to 5 times sine of 50 over 4. That goes into a calculator. 5 times sine of 50 divided by 4 is about 0.9576. Sine of B is that, and then we do the inverse sine of that on both sides. And get our angle B, which is about 73 degrees. Now, I'm wondering if any of you are sort of getting a little bit worried about this step, because there was all that business from yesterday that we saw in the 3-minute review that sort of thing, the sine of an angle, has got 2 answers. And we are worried about that a little bit. This is the note. Continue. In cases like the one that we just did, we must be careful when we're finding angles using the sine law. Recall that equations like sine B equals point, that one that just came up, have 2 solutions. It says we must be aware that sometimes we want an obtuse angle, even though our calculator gives us the acute angle. So remember, the calculator will always give you the acute angle. If we want the obtuse angle, we have to do an extra step. We have to do some more work. In the example 1b above, the diagram showed that we were interested in an acute angle, so we didn't need to find the obtuse angle. It was all good. So nice. I'm going to stop there and we'll pick it up in part 2.